All right, guys. So today we're going to cover some more solving equations with radical or rational exponents. So let's start with number 3. So we're going to solve this equation, okay? And remember that we want to isolate whatever has the radical or the fraction exponent. So we're going to have to isolate just the square root of x minus 2. Okay, so that means I need to get rid of the x. So I'll subtract x on both sides to bring that to the right. So now I have negative square root of x minus 2 equal to 4 minus x. All right, next I also have a negative 1 in front. So that's obviously multiplying to that radical. So I'm going to go ahead and divide by negative 1 to get rid of that. And remember, when dividing, just like multiplying, you have to do that to every term. So on the right-hand side, 4 divided by negative 1 would be negative 4. Negative x divided by negative 1 would be positive x. And I just switched the order of those terms so I could have the x written first. All right, now that I have the radical isolated, I will go ahead and raise both sides to the power of 2. So that square root will cancel out the square, and I'll get x minus 2 on the left-hand side. On the right-hand side, we have x minus 4 times x minus 4. So this will be x times x, which is x squared. The negative 4x minus 4x is negative 8x, and negative 4 times negative 4 is positive 16. All right, so I have a quadratic here. So I'm going to go ahead and bring everything to the right-hand side so I can have equal 0. So I'm going to subtract x and add 2. Subtract x, add 2. So I have 0 equals x squared. Negative 8x minus 1x is negative 9x. 16 plus 2 is 18. All right, now we have to factor to solve, if possible. So our coefficient is 1, multiplies to 18, adds to negative 9. I can't think of anything. Oh, negative 3 times negative 6, negative 3 plus negative 6. So that works. All right, so this factors into x minus 3 times x minus 6. Negative 3 times negative 6 is positive 18. Negative 3x minus 6x will be negative 9x. Okay, so now I can solve. So I have two solutions, x equals 3 and x equals 6, right? Now, remember, with all of these equations, we always have to check our answers. So first, let's go ahead and check. Let's check x equals 3 first, just because it's written first. So x minus square root of x minus 2 equals 4. Maybe. We'll see. 3 minus 2 is 1. The square root of 1 is 1. And 3 minus 1 is 2. Does 2 equal 4? No, right? 2 does not equal 4. So this is actually extraneous solution. Okay, so that is not a valid solution. Let's go ahead and check x equals 6 now. Okay, so again, x minus the square root of x minus 2 equals 4. And 6 minus 2 is 4. Square root of 4 is 2. So 6 minus 2 would be 4. 4 equals 4. So yes, this is a good and valid solution. So the only solution for this equation is 6. Okay, so go ahead and pause this video now and try number 4 on your own. All right, so solving this equation, again, we want to always isolate the radical, right? So whatever radical it is, you want to go ahead and isolate it. So first I'll move over the terms positive x and 5 by subtracting x and subtracting 5 to both sides. So now I have negative square root of 1 minus x equal to negative x minus 5. Then I want to get rid of the negative 1, so I'll go ahead and divide by negative 1 on both sides. And remember, you do the division to every term, right? So on the left-hand side, we have the square root of 1 minus x, and on the right-hand side, we have x plus 5. Okay, from here, we want to get rid of the square root, so I'm going to go ahead and square both sides. And the square root and the square will cancel, so on the left-hand side, I have 1 minus x. On the right-hand side, x plus 5, 2 copies multiplied together. So x plus 5 times x plus 5 would give us x times x, which is x squared. 5x plus 5x is 10x, and 5 times 5 is 25. Okay. Moving right along from there, let's go ahead and bring everything to the right-hand side. All right, so we'll subtract 1 and add x. Subtract 1, add x. So we have 0 equals x squared plus 11x plus 24. Okay, let's try to factor this one to solve. So multiplies to 24, adds to 11. 6 times 4 would 6 and 4 add to 10. 8 times 3. 8 times 3. Yep. 8 times 3 multiplies to 24. 8 plus 3 adds to 11. So this will factor into x plus 8 times x plus 3. So we have two solutions, potential solutions, x equals -8 and also x equals -3. So let's go ahead and check both of these. So I guess we'll start with -8 first. So let's check -8. So our original equation is negative square root of 1 minus x plus x plus 5. And does that equal 0? That's the question. So square root of, well, 1 minus -8 is 1 plus 8, so that's 9. Square root of 9 is 3, so this is -3. And plus -8 would, of course, be -8, and 5 is +5. Now, -8 minus 3, -3 minus 8, that's -11, plus 5 would be -6. Does -6 equal 0? No. So -8 is actually extraneous. So let's look at -3. Let's check that one. So let's check -3. Okay, so negative square root of 1 minus x plus x plus 5. Does that equal 0? Okay, 1 minus -3 would be 1 plus 3, so that's 4. Square root of 4 is 2, so this is -2 minus 3 plus 5. Now, -2 minus 3 is -5. -5 plus 5 is 0. 0 equals 0. Yes. So 3 is the only correct solution here. All right. So remember, always check your answer. Okay. So let's move on to some more examples. So number 7, right? We have a fraction exponent, right? Now that fraction exponent is to this expression right here. So we need to isolate that. Right now we have the 3 that's on the outside. Notice that that 3 in front, right? This 3 in front is not a part of that expression that has the power. So we need to get rid of that to isolate that expression that has the power. So I'm going to divide 3 on both sides. And I'm just going to use my calculator for this because I don't want to do the division by hand. So 3072 divided by 3 is 1024. Okay. Now on the left-hand side, we have 3v plus 7, and that has the power of 5/3, okay? So now that that is isolated, we can get rid of that power of 5/3 by raising both sides to the power reciprocal. Because power of a power will multiply, right? So I'm raising both sides to the power of 3/5. Power of a power will multiply, and that will multiply to be 1. So 3v plus 7 to the power of 1 would, of course, just be 3v plus 7. Now, on the right-hand side, I can try to use my calculator for this. 1024 to the power of 3/5. Hopefully, that's a nice whole number. And it is 64. So now we can go ahead and solve this like regular. Subtract 7 on both sides. So we get 3v equals 64 minus 7, which would be 57. And then divide 3 on both sides. We get v equals 57 divided by 3. Not sure what that is, and again, I don't want to think about it. Being a little lazy. So v equals 19. All right, now let's go ahead and verify that answer before we circle it. So let's check. So 3 times 3 times v plus 7 to the power of 5/3. Does that equal 3072? I don't know. Let's see. So remember, whenever you're doing parentheses, you work from the inside out, right? So I need to multiply first. 3 times 19 is 57, right? 57 plus 7 is 64. So let me just write that right now. So I simplified on the inside. This is 64 to the power of 5/3. Does that equal 3072? So remember, you got to do exponents first, and that exponent is only going for the 64, okay? Because that's the only thing that's in parentheses, right? So 64 to the power of 5/3, okay, is 1024 times 3 is 3072. So yes, 3072 equals 3072. This checks out, and now I can circle v equals 19. That is my solution. All right, let's try number 9. So on number 9, again, we have a radical. Okay, now this radical is not by itself, right? We have a 6th root, okay, and then we have a plus 1. So we need to subtract the 1 to bring it to the other side so that we can get the 6th root of 3k minus 5 by itself. 3 minus 1 is 2, so now we have the radical isolated. Now, this is not the square root, it's the 6th root. So I will need to raise both sides to the power of 6 to cancel out that radical. So on the right-hand side, now I'll have 3k minus 5, and 2 to the power of 6 is 64? Yes. And then now I can solve this like regular, add 5 on both sides, and then divide 3 on both sides. So we end up with k equals 23. Okay, now I am boxing this, but I should probably not get ahead of myself. I'm just assuming that this is going to work. Remember, you always have to check your solution. So let's do 6th root of 3 times k, which we found k is 23, minus 5, and then plus 1. So 3 times 23 is 69, I believe. Yep. And then minus 5 is 64. And then we're taking the 6th root, so 6th root of that 64, which is 2. Okay? So all of this is 2. 2 plus 1 is 3. 3 equals 3. So yes, this is a good solution. And we can box it. We already did because we got a little ahead of ourselves. All right, so go ahead and pause this video now and try 8 and 10 on your own. Okay, so let's take a look at number 8, right? Now, number 8 is almost isolated. We just have a 4 that's multiplying in front, right? Remember, you always have to, whatever has the power, right, with the variable, you have to isolate that first. So I have to divide 4 on both sides, okay? Now, dividing 4 to a fraction gets a little weird because, like, you don't want to write 4/3 divided by 4, right? I mean, you could write it like this and then change the division to multiplication, flip, but I find it a lot easier. Like, you know, if you multiply, right, to a fraction, if I take 2/3 and I'm multiplying 4, you'd multiply that to the numerator, right? Well, what happens if you're dividing? Well, when you're dividing a number, right, you end up multiplying that to the denominator because you end up flipping. So if you're multiplying, you multiply to the numerator. If you're dividing, you technically multiply to the denominator. Because dividing 4 is the same thing as multiplying 1/4, so these two are the same thing. So I just quickly remember it. If I'm dividing a whole number, I just multiply to the denominator. So we end up with 4 over 12 equals v plus 19 to the power of negative 1/4. Now 4 over 12 does simplify, so I'll write that in its simplest form, which would be 1/3. Okay, and now we're ready to keep moving. Now, v plus 19 has the power of negative 1/4. So I need to get rid of that power by raising both sides to the reciprocal of that power. So I'm going to raise both sides to the power of negative 4. Now, negative 1/4 times negative 4 will multiply to 1. So I'll have v plus 19 to the power of 1, which would of course just be v plus 19. On the left-hand side, 1/3 to the power of negative 4 will really be 3 to the power of positive 4. So this will end up being 81. You could also use your calculator, but you do waste some time if instead you can just think about the problem, right? Instead of having to put the fraction in parentheses, then write the exponent, negative 4. Like, it just takes a little bit of time to put it into your calculator. If you don't just think about it quickly that way. But you can if you need to. Now we could subtract 19 on both sides. 81 minus 19, I'm going to be real lazy here. I'm not going to think about this one, is 62. So we end up with our solution is 62, our potential solution. How do we know it is a valid solution? Well, we need to check it. So let's go ahead and check 62. So 4/3 equals 4 times v, which we found v to be 62, plus 19 to the power of negative 1/4. Okay, so we have to check, is that actually true? So first let's start on the inside of the parentheses. 62 plus 19 is 81. So we have 81, which is raised to the power of negative 1/4. All right, so that's 1/3. So we have 4 over 3 equals 4 times, and we got this is 1/3. Now 1/3 times 4 will be 4/3, so 4/3 equals 4/3. Yes, this is a good and valid solution. V equals 62 is my answer. All right, let's take a look at number 10. Now, number 10, the radical is already isolated. Great. This is already isolated by itself. So now all I have to do is get rid of that radical. Now this is the cube root, so I'm going to raise both sides to the power of 3 to cancel out that cube root. So we have b minus 21 equals 4 to the power of 3, which is 4 times 4 times 4, which is 64. Okay, then I could add 21 on both sides. So I end up with an answer of b equals 85. Now we have to check it, right? Let's go ahead and check this solution. Cube root of 85 minus 21. Does that equal 4? Well, 85 minus 21 is 64. The cube root of 64 is 4. So yes, 4 equals 4. This is a good and valid solution, and you can box it. All right. Let's try one more question together, and then I will leave you to try these 3 on your own, okay? Now, this direction does say to solve, and it gives you the reminder to check for extraneous solutions. But usually you won't see that on a question. You should always know that if you have a radical or rational exponent equation, you should check your for any extraneous solution. So always check your solution. Okay, I wanted to do number 1 with you because this is a little bit different, right? Normally we have just the radical around one expression, or we have just a rational exponent over one expression. So what do we do when it's multiple expressions? Well, what you want to do is isolate one of them. I would isolate the one that is more complex, the one that has more terms and things happening, operations on the inside of the radical. So I'm going to isolate the square root of x minus 7. And I'm going to bring this term to the right by subtracting the square root of x. Okay, so now I have the square root of x minus 7 equal to 7 minus the square root of x. Okay, so now I'm going to go ahead and get rid of the radical by squaring both sides. Okay, so I have x minus 7 on the left, and on the right hand side I have two copies, 7 minus square root of x times 7 minus square root of x. And I will need to multiply these two together. So let's do that. 7 times 7 would be 49. 7 times negative square root of x will be negative 7 square root of x. Negative square root of x times 7 is negative 7 square root of x. And negative times a negative is a positive. Square root of x times square root of x is positive x. Okay, on the left hand side, of course, I'm just going to go ahead and bring that down. Now, the middle combines, right? We have negative 7 square root of x minus 7 square root of x would be negative 14 square root of x's. Okay, and I'll bring down the 49 and the positive x. Okay, so now you see that now I have only one radical. So now the goal is to isolate that radical. So I'm going to subtract 49 and subtract x to bring those terms to the left-hand side. Now, x minus x would cancel. Negative 7 minus 49 is negative 56. And on the right-hand side, we have negative 14 square root of x. Okay, next up, we can go ahead and get rid of that negative 14 that's multiplying to that by dividing negative 14 on both sides. And 56 divided by 14, I think is it 4? Yep. So now we have 4 equals the square root of x. And how do we get rid of the square root? Well, we square both sides. So our solution that we have is 16 equals x, or x equals 16. So let's go ahead and check it. So square root of 16 plus the square root of 16 minus 7 should equal 7 if this is a valid solution. 16 minus 7 is 9. The square root of 9 is 3. The square root of 16 is 4. 4 plus 3 is 7. 7 equals 7. This checks out. Yes, this is a good and valid solution. I can go ahead and box it. All right. So now that I have gone over those, go ahead and try 2, 3, and 4 on your own. Pause this video now. Okay, let's run through these pretty quickly since we've done a lot of examples together already. Subtract 1 on both sides, so we have 3650, dyslexia moment there, 3645. And on the right-hand side, we have 5 times 4r plus 17 to the power of 3 over 2. Now, we still don't have this fraction, exponent, expression isolated. So I'm going to divide 5 to get it by itself. 3645 divided by 5. Oops, didn't mean to do that. 3645 divided by 5 is 729. And then I need to get rid of that power. So I will raise both sides to the reciprocal power, which would be 2/3. On the right-hand side, power of a power multiplies, so that power would be 1. So we just have 4r plus 17. And on the left-hand side, 729 to the power of 2/3 is 81. Subtract 17 on both sides. Oops, only one minus. 81 minus 17 is 64. And then divide 4 on both sides. We get r equals 16. And I'll just verify 64 divided by 4, 16. Okay, so let's go ahead and just check that solution. 3646, does that equal 1 plus 5 times 4 times r plus 17 to the power of 3 over 2? Okay, so again, let's work from the inside of the parentheses, right? 4 times 16 is 64. 64 plus 17 is 81. Now, remember, you have to follow the order of operations whenever you're simplifying, right? We're simplifying on this right-hand side. So we just simplified all of this that was inside the parentheses, and we got 81. Then we have to do exponents, right? So 81 to the power of 3 over 2 is 729. So I have 1 plus 5 times 729. Does that equal 3646? That's what we're checking. And 729 times 5 is 3645 plus 1 is 3646. So yes, 3646 checks out. This equals 3646. So this is a correct and valid solution, and I can go ahead and box it. Let's move on to number 3. Okay, now number 3, we want to isolate these radicals. So I'm going to go ahead and add n on both sides. Okay, and I usually like to write my variable first, so I will rearrange this to n plus 2. And I'll just bring down the left-hand side, square root of 6n plus 19. Now I have the radical by itself, so I would go ahead and raise both sides to the power of 2. The square root and the square will cancel, so I'll get 6n plus 19 on the left-hand side. On the right-hand side, I have n plus 2 times n plus 2, which would be n squared plus 4n plus 4. And now I have a quadratic. Go ahead and subtract 6n and subtract 19 on both sides. All right, so on the left-hand side, we have 0, and on the right-hand side, we have n squared minus 2n minus 15. So now I need to factor this to solve, okay? Multiplies to negative 15, adds to negative 2, negative 5, and 3. So this will factor into n minus 5 times n plus 3. Okay, so we have two solutions, n equals 5 and n equals negative 3. Now again, these are potential solutions, so we have to go ahead and check them. Let's first check positive 5. So negative 5 plus the square root of 6 times 5 plus 19, does that equal 2? Now 6 times 5 is 30, 30 plus 19 is 49, the square root of 49 is 7, and negative 5 plus 7 is 2. Yes, so this checks out. This is a valid solution. We can box it. Now let's go ahead and check negative 3. That could also be a solution. We could have maybe 2. Who knows? Let's go ahead and check it. So negative 3 plus the square root of 6 times negative 3 plus 19. Does that equal 2? Well, 6 times negative 3 is 18. 18 plus 19. Negative 18 plus 19 will be 1. Square root of 1 is 1. And we have negative 3, so that would be positive 3. 3 plus 1 is 4. Is 4 equal to 2? No. So this one is extraneous. Remember, even though this is considered an extraneous solution, it's not actually a valid solution. It's just called extraneous solution because it's a solution that we toss out. So if we're tossing it out, that means that it's not actually a solution, right? So the solution here, the only valid solution would be n equals 5. All right. Last one, let's take a look at number 4. So number 4, we have the square root of something equal to the square root of something else. Now, both are just square roots, so we could just go ahead and square both sides, right? It would cancel the square root here, and it would also actually cancel the square root here. So we have x over 10 equal to 3x minus 58. All right, so let's go ahead and multiply 10 to both sides to just get rid of that denominator, right? And remember, when you multiply, just like when you divide, you have to do that to every term. So we have x equals 30x minus 580. Okay, let's go ahead and subtract 30x on both sides. So we have negative 29x equals negative 580. And then we can divide negative 29 on both sides. So we get x equals whatever 580 divided by 29 is. So negative divided by negative will automatically give me a positive, which is 20. All right, let's check it. Remember, there could be no solution, so you always have to check your solutions, okay? So we have the square root of 20 over 10. Does that equal the square root of 3 times 20 minus 58? Okay, well, 20 divided by 10 is 2. So we have the square root of 2 on the left. And on the right-hand side, we have 3 times 20, which is 60. 60 minus 58 is 2. So we have square root of 2 equals square root of 2. Yes, so this is a good and valid solution. All right, guys, so I hope that those more examples were helpful, and I will see you guys in the next video. Bye!